Welcome to day 5 of the AWS AI Practitioner series. Today, we are going to explore some of the most important topics on AI, and these are very important for our exam also. Those are types of machine learning, AWS SageMaker, and few other topics as well. So, let's start today. S- So, in this section, we'll break out the three main types of machine learning you need to know for AWS. That is supervised learning, unsupervised learning, and reinforcement learning. Along with that, we'll cover the transfer learning also. I'll give you simple real life examples so you can remember them instantly in the exam. So first, what is supervised learning? Supervised learning is when the model learns from the labeled data. So what is labeled data then? Means you already know the correct answers during the training. Think of like how I am trying to explain the things, like a teacher giving you practice questions with the answers provided. For example, in real life, predicting house prices. We give the model past data, house size, location, number of rooms, along with the actual sale prices. Then the model learns the relationship that and can predict the price of a new house, right? So this is the supervised learning. So you are giving input and then the output mapping. You are giving the input and output both. So the main goal is that it can predict outcomes for unseen data. Examples, there are multiple examples, that email spam detection. You are categorizing it is spam, this email is spam, this is not spam. Any disease prediction from medical records, house price prediction, the example I gave. And these algorithms, please try to remember these algorithms in the each category of learning. So supervised learning, there is linear regression, logistic regression, random forest, neural networks, all are under supervised learning. Then what is unsupervised learning? Unsupervised learning is when the model works with unlabeled data. Means there are no correct answers given. It's like asking students to group themselves based on shared interest without telling them the groups in advance. A real life example, maybe a supermarket analyzing customer purchase history to find the natural groupings. Maybe one group buys the most fresh produce thing, another buys mostly snacks. In AWS, if you think this is common in clustering tasks, suppose customer segmentation with Amazon personalize. So the main thing you need to remember in unsupervised learning, there is you need to find the pattern or structure. There is nothing like you will like the in the label data you have input and proper output you have mapped. It's from the past thing you need to find the patterns and the structure, that is called unlabeled data. So main goal is you need to discover the hidden groups or reduced dimensions. So you means the model will do, and examples like the example I gave, the customer segmentation in retail. It can be music recommendation, grouping similar songs, right? You in Netflix, you have seen that based on the patterns of movies you have seen or the series you have watched, it used to predict you or give you suggestions. You should see this movie also. So this kind of thing is part of unsupervised learning. Most famous algorithm in unsupervised learning is K-means algorithm, PCA, hierarchical clustering. There is another kind of learning which is called reinforcement learning. Reinforcement learning is when an agent learns by interacting with an environment and receives rewards or penalties. So it's like trial and error. Think like suppose a robot vacuum. It tries different cleaning paths, gets a reward for covering more floor efficiency and a penalty for bumping into furniture. Over time it learns the best route, right? So you can think of a maze game also, this kind of this where you have reward and penalties, right? In AWS, a fun example maybe a AWS deep racer. There is a small car, you might know, that a physical device, AWS Deep Racer, a small car that learns to drive around a track by maximizing its reward score. So think like whenever in the exam you will see this rewards, penalties, trial and error kind of thing, it's actually pointing to reinforcement learning. The example I gave that robotics or for warehouse automation, it can be self-driving cars also. Key concepts are agent, environment, actions, rewards and policy. Okay. So from the exam tip perspective, these three are the main types of machine learning: supervised, unsupervised, reinforcement. What is supervised? Whenever you have labeled data, prediction or classification with labels. Unsupervised means you are having unlabeled data. You need to find the clustering and pattern discovery without labels. Reinforcement, rewards and penalties. Agent is learning via rewards and penalties. There is another kind of learning which is not typically part of the main learning, but that is called transfer learning. Transfer learning is the practice of taking a pre-trained model, typically built on a large and general data set, and adapting it to a new but related task. So the main goal, you are not starting from the scratch, right? You are not starting from the beginning. Instead of training from scratch, the existing models learned patterns that are fine tuned with domain specific data. It's already trained, you are using it so what the benefit you will get? You will get a faster development time, reduced computational cost and improved accuracy for the target application. We'll practice few questions on transfer learning also, but just to remember for the exam, there is another kind of uh, learning exists, that is called transfer learning. Now comes to the most important topic for this exam. You will see at least 40% questions in the exam, and for your knowledge purpose also, whenever you need to do any hands-on in AWS for AI, that you will do it through SageMaker, means where you can build your model, maintain everything, right? So what is SageMaker? Amazon SageMaker is actually fully managed service that helps developers and data scientists to build, train, and deploy and any machine learning model very quickly. So why we need SageMaker? We need SageMaker for multiple capabilities, right? It can give you predictive analysis. For example, uh, if we need to predict your AWS score based on the past practice test, hours studied or quiz performance. So what kind of model you use? This is called supervised learning, right? You are classifying, okay, I can predict that person X will get this score. So how many hours he practiced, how many hours he studied, what was his performance in multiple questions. So this can be a predictive analysis, and it is part of SageMaker. It can do that. Another is customer behavior and sales forecasting. This also it can do. Suppose we need to predict which product a customer is likely to buy next month based on the purchase history. That is also part of supervised learning, but SageMaker can do that. Image classification. We need to detect a defective product in a factory using photos from quality control cameras, for example. This can also done by SageMaker. If we need to do the example I gave previously, suppose customer segmentation. So based on their shopping habits to send personalized promotion, this can be done, but that will be unsupervised learning. SageMaker can do fraud detection also. Suppose we need to identify unusual credit card transaction automatically. So supervised learning or by anomaly detection, we can do these things, right? So for exam purpose, you need to understand what are the main capabilities of SageMaker. It can collect and prepare data, build and train models, and deploy and monitor models. So you can directly import data from Amazon S3 or any kind of data source, and you can clean and pre-process the data. We'll go into those in another session, that what is feature engineering before you import the data in the model. So how you can clean the data and all those things. So then you can build and train the models using some built-in algorithms. So we'll cover in next session like what is XGBoost and linear learner, this algorithm. So there are multiple algorithms present in AWS, which by which we can build the models, or we can write our own ML code also, and deploy. After that, building the model and train the model, we can deploy and monitor models also. We can deploy the models just with one click. We have capabilities in SageMaker. I will show it to you how you can just with one click you can deploy the model. Then after deploying, we need to monitor. So SageMaker has SageMaker model monitor, by which we can monitor the prediction performance over time. So what is the key takeaway for a SageMaker? So everything from model perspective, you will can collect and prepare data, build and train models, deploy and monitor models. So in total, so it's a fully managed service, and you can handle the entire life cycle, right? End-to-end ML life cycle, from data training, deployment, monitoring, without needing to manage any server or any infrastructure. That is SageMaker. Okay, now this is a very common thing, a common question asked by many clients, that is there any capability that we do not need to train our model? Is there any capability in AWS that your model will be automatically trained? So for this part, SageMaker has a capability that is called SageMaker Automatic Model Training. Okay, so what it does? First, we need to define the what is the objective metric. We need to tell SageMaker that what success looks like. That is our objective metric, right? This can be accuracy, F1 score, RMAC, depending on the problem. What is the objective metric? Second is uh, SageMaker automatic model training auto selects. So from there, model training takes over. It chooses hyperparameter ranges, picks the search strategy, then sets the maximum runtime, even apply early stopping rules also, all without us lifting a finger. So I'm just going through this diagram how internally it does. But from exam perspective, you just need to know that SageMaker has this capability. But from knowledge perspective, you should know how it does. So first I told that you need to define the objective metric, means how you will understand that it is success or not, that you need to define with some accuracy, that you need to have a 90% accuracy, or your F1 score will be this much. Then only you can understand that it is success or not. Then you need to SageMaker AMT or auto selects that what are the hyperparameter, search strategy, blah, 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 blah. And then how multiple training jobs launch with different configurations. So SageMaker can launch multiple training jobs in parallel, each with different configurations, to explore the best possible setup. That is also possible here. And from there, best configuration will be selected. Finally, it will select the best configuration based on the objective metric that you define on step 1. Okay, that will save us the time, money, and avoiding suboptimal models, right? So in short, this AMT or automatic model training is your autopilot for hyperparameter training, and it is smarter, faster, and obviously it can serve in your entire business. Okay, so from exam perspective, AMT, when you will choose AMT or automatic model training of SageMaker, if you see the question is saying that auto selects the hyperparameter, saves time and cost, improves performance, and without any manual intervention, then you should go for SageMaker automatic model training. Okay, this is another part, that SageMaker model deployment. This is very normal with any kind of cloud if you have previously worked. So, but in SageMaker, uh, there are few questions comes and you need to know the this concept also. What is real-time inference, serverless inference, asynchronous inference, and batch transform? Real-time inference you can understand by the naming. It's a real time. It's a there is no latency. It's a very fast millisecond to second kind of latency. It's a but there are limitation with real-time inference that it can serve up to 6 MB request only. And obviously, it will be very fast. Maximum processing time is 60 seconds. It is best for instant predictions for applications or websites when user expects the result simultaneously or immediately. Sorry. So that is real-time inference when you need things instant or immediately. Another is serverless inference. It is also kind of real time only. So it is also very fast. And here maximum data per request can be only 4 MB. So little lesser than real time. But you do not need to manage any infrastructure, any server. Great for occasional or unpredictable traffic. Suppose you know that you need this model only for 2 hours or 1 hour, but you do not know that in that 1 hour the traffic can be 10,000 hits or 100,000 hits. Then serverless inference, and you do not need to, you are not managing your infrastructure or server. Then this kind of specific requirement, serverless inference is your best choice. Another is asynchronous inference. That is medium. The latency is medium. Obviously, it can take seconds to milliseconds. But the one benefit is the data you can send per request, it can be up to 1 GB. There can be questions that if we need to send data up to 1 GB, not crossing 1 GB. Okay, then asynchronous inference you should think. And the maximum processing time is up to 1 hour because it is handling a large file. So jobs can take huge time or large time to process. But result will be good, right? If you do not need the result immediately, you can choose still in asynchronous inference. And for large payloads of means always go for asynchronous inference. Another is batch transform. The latency, obviously, batch it is the slowest among this. It can take minutes to hours, but if you want the suppose offline jobs, you do not want a kind of that immediately, or you do not have very large file. You want that we have a huge data set, but it is in bulk. It is not like every request have 1 GB, right? It can have up to 100 MB only, but there are huge data sets and you want to process it offline. Your business requirement is not that critical. You need the things immediately, or speed, you are not bothering about speed. Then batch transform is your uh, correct deployment type. Okay, I hope that is clear to you. Now coming to the questions. So question 1, the company is using domain specific models. The company wants to avoid creating new models from the beginning. The company instead wants to adopt pre-trained models to create models for new related tasks. Which ML strategy meets this requirement? I hope the second sentence, whenever you read, you understand what should be the model, what should be the learning things here. The company wants to avoid creating new models from the beginning. I was telling about the same thing, concept in transfer learning. So the answer should be transfer learning. They don't want to start it from the scratch. Question 2, the company uses Amazon SageMaker for its ML pipeline in a production environment. The company has large input data sizes up to 1 GB. This also I was saying, right, up to 1 GB, and processing times up to 1 hour. And the company needs near real-time latency. So it cannot be batch, right? And up to 1 GB, I was telling that this kind of questions can come. So this implies to which kind of inference? Obviously, it should be asynchronous inference. Okay. So question 3, a company needs to use Amazon SageMaker for model training and inference. The company must comply with regulatory requirements to run SageMaker jobs in an isolated environment without internet access. Okay, just little bit cautious you need to see. Normally, if you do not have this line, the last line it's mentioned in an isolated environment without internet access. Apart from that, this question can be, so we can do it in a multiple way, right? Regulatory requirements, but if they mention isolated environment without internet access, there is only one concept. With this we can solve this question or solve this thing. In SageMaker, some concept is called network isolation. So network isolation is in the SageMaker ensures that training and inference jobs run in a fully isolated environment without internet access. So whenever you see this kind of this question or this kind of question without internet access, think about network isolation in SageMaker. We do not need to see any other option. Question 4, an e-commerce company is using a generative AI chatbot to respond to customer inquiries. The company wants to measure the financial effect of the chatbot on the company's operations. Which metric should the company use? A, number of customers inquiries handled. B, cost of training AI models. C, cost for each customer conversation. D, average handle time. Okay, so by reading this, what should be the answer? You think? Take some time. Company wants to measure financial effect of the chatbot. So obviously, whenever you are thinking about financial effect, so you should think about the cost. So here, cost of training models, it can be, but mainly for the financial effect on chatbot, it is not chatbot. You are not thinking about the training of AI models cost, right? Rather than how much cost you are spending on each customer conversation is a better from the operational perspective. So that metric should be the company should use. Question 5, a company is using Amazon SageMaker Studio notebooks to build and train ML models. The company stores the data in Amazon S3 bucket. The company needs to manage the flow of data from Amazon S3 to SageMaker Studio notebooks. Which solution will meet this requirement? I will cover Amazon SageMaker Studio in my next session, but this question doesn't need that knowledge. It is saying that with SageMaker Studio notebooks, it is trying to build, and if the data is stored in S3, company needs to manage the flow of the data from S3 to SageMaker Studio notebooks. Which solution will meet this requirement? A, use Amazon Inspector to monitor SageMaker Studio. B, Amazon Messi to monitor SageMaker Studio. C, configure SageMaker to use VPC with an S3 endpoint. D, configure SageMaker to use S3 Glacier Deep Archive. So here there is a new concept maybe you are not aware of if you are not familiarized with AWS. So there is something called S3, Amazon S3 VPC endpoint. So by placing SageMaker Studio in a VPC and configuring a S3 VPC endpoint, you can actually enable a secure control data transfer. So between the SageMaker and S3 without traversing the public internet, it's a concept of a little bit of AWS networking, but this type of questions can come in the exam. That's why I just showed you this question. So the answer should be C. Okay. The last question, a robotics company is exploring different machine learning techniques to improve the decision-making capabilities of its autonomous robots. The team is particularly interested in reinforcement learning as a way to enable robots to learn from their interactions with the environment and improve performance over time. To ensure they understand the underlying mechanics and applicability of this approach, they need a clear explanation of how reinforcement learning works, how it differs from other machine learning methods. So reinforcement learning, you remember, right? Penalty, rewards, those kind of thing. So how does reinforcement learning work? Option A, reinforcement learning relies on unsupervised learning techniques to cluster data points into groups without any specific feedback mechanism. B, reinforcement learning involves an agent interacting with an environment by taking actions and receiving rewards or penalties, learning a policy to maximize cumulative rewards over time. C, reinforcement learning uses supervised learning algorithms to label data and make predictions based on those labels. D, reinforcement learning transforms raw data into new feature space to reduce dimensionality and improve the accuracy of the model. So, whenever I am talking about reinforcement learning, it actually works by having an agent take actions in an environment, receiving rewards or penalties, right, based on some actions. And learning policy always aims to maximize cumulative rewards over time. So option B is the exact thing for reinforcement learning. So option B should be the correct answer. So uh, we will cover in our next videos. There are multiple other concepts that we need to go through for the exam, like what is bias, hallucination, overfitting, underfitting, leakage. And from SageMaker's perspective, I will cover model monitor, SageMaker Clarify, Jumpstart, Studio, Feature Store, as well as XGBoost and little bit on class imbalance, RNN, CNN, and GAN. So thank you. Thank you for joining the session. See you in your next video.